Hey kids, it's Dr. Rones here with your lesson on Chapter 4, Section 5. This is about direct variation. We are edging into writing equations in slope-intercept form so that we can graph them, graphing more efficiently, and it's an exciting time for you. Before we do that, we need to talk about direct variation. So what we mean by that is two quantities that vary directly. So for example, if I am going to drive a certain number of miles with my car, I have to have a certain amount of gas. If I drive a lot of miles, I need a lot of gas. If I drive a few miles, I need a little bit of gas. If I drive no miles, I need no gas. Or if I am baking chocolate chip cookies. If I'm making one recipe, I need a certain amount of chocolate chips. If I'm going to do a triple batch, then I need to do a triple amount of the original recipe. If I make no cookies, I need no chocolate chips. The example that we used in class today is an imaginary pizza party, because I can't actually feed kids anymore, where I am going to invite students to come eat pizza in my classroom, and everyone gets 2 slices of pizza. Everyone gets 2 slices regardless of how much I like them, what their grade is, how much they like pizza, how much the pizza costs. Like, everybody gets 2 slices of pizza. So if I have 20 kids who show up, I need 40 slices of pizza. If I have 2 kids that show up, I need 4 slices of pizza. If nobody shows up, I don't need any pizza. So this is the example that we are going to use in a moment. The equation that represents direct variation is this: y equals kx. Don't get too attached to that because it's going to morph when we talk about slope-intercept form. But for now, just know that the k, which is ironic, constant, starts with a CK sound. So if it's a little help for you, you can think of constant with a K. Anyway, so the constant is this position, the one that comes between the equal sign and the x. That's the value that is constantly going to be applied to the x. So in this case, where I need 2 slices of pizza for each guest, what that means is I need, and y equals is almost always the total. I would say 98% of the time, the total needed is 2 slices of pizza. So we represent that with a 2 slices. That's a little redundant if you look at the top. Anyway, for each guest, but I don't know how many guests are going to show. So that's my unknown. That's my variable. It could vary. I could have 30 people or 2 people. So that's the unknown. So times the number of guests. Cool. All right. So let's see what that looks like on a coordinate plane in the form of a graph. So here you see, I need to show you this whole big section at once. Let me do a little origami here. Okay. We are going to compare the constant in an equation with its slope to see if we see any patterns here. So this line is represented by this equation. You don't know how to graph that yet. You will soon, but you're just going to have to believe me for now. And so these are 2 points that are on the coordinate plane, 1, 2, and -1, -2. Well, let's find the slope of that line. The slope would be y2 minus y1 over x2 minus x1. Remember, it's this minus this over this minus this. Or the slope is -4 over -2. A negative over a negative is a positive. 4 over 2 is 2. When we look at the equation, the number in the k spot, remember direct variation is y equals kx, the constant here was 2, and the slope was 2. Coincidence? We shall see. Let's find the slope of this line. Here is point 2, -1, and -2, +1. Let's calculate our slope. You know what? How about you calculate the slope? Hit pause, and then start up again. Did you do it, or did you just wait for me to talk again? Haha. I wonder if people actually pause to see if they can do this independently. Two negatives are a positive. 1 and 1 make 2. Negative 2 minus 2 is negative 4. Simplifies to a negative. 2 over 4 simplifies to 1/2. But look, that was also the constant. What? The constant was also negative 1/2. Can you make a prediction? Oh, but this one's tricky. Y equals x. Well, there isn't a constant number. Do you know what would it be? How many x's do I have? It's a singular x. I hope you didn't say 0, because 0x would be nothing, right? A singular x, that's 1x. Let's see if our slope is 1. You go ahead of me. Ugh. That should be a negative sign. I won't be lazy. I'll make pretty notes for you guys. Maybe 1 over negative 1. Ooh, it looks like the same thing on the top and the bottom. Negative 2 over negative 2. Anything over itself is 1. Hey! K is 1, slope is 1. They are the same. All that to prove that the slope and the constant is our B are the R. I should stop talking about is an R. They're the same in direct variation. Slope and constant are the same for direct variation. And the graph of a direct variation equation always goes through the what do they all have in common? Oh, look, through the middle, through the middle, through the middle. What do we call the middle? Yeah, it's the origin. And its coordinate, of course, is 0, 0. Cool, it looks like it's looking at you. Boop, boop. Haha. Okay, so let's apply that to something a little bit more difficult. So let's say, hypothetically, that, ooh, you're out of focus. Try again. Eesh. Okay. If x is 5 and y is 20 and they vary directly, ooh, now how do we find the constant? So another way to think about that is if a line goes through point 520, because this is the x and this is the y, and also the origin, what's the slope? Ooh, that's a fantastic thing to be able to do. Okay, just like what we learned when we were finding the missing part of a coordinate when we know the slope using slope-intercept form, if we know all but one piece of an equation, we can solve for the missing piece. So we say here that y is 20, so let's put in 20 for y. I'm using parentheses because that's a good habit to get into when you're subbing in. Don't know what k is because we're solving for constant, and the x is 5. Well, it appears that k is being multiplied with 5. The reverse of multiplication is division, so 20 over 5 is 4. Or we could say k equals 4. Okay. So let's say, for example, we want to know how much money each person owes for a lunch, if we want to just put this in a context. Let's say we all go out, me and 4 other friends, so 5 of us go out for lunch, we enjoy a meal, and the bill is $20, and we all got the same thing. How much does each person owe? Every person owes $4. Or the constant is 4. And you could use that, well, if we go to the same restaurant or the same food and say we brought 10 people. If it's $4 a person, we could expect the bill to be $40. So we can use these equations in the future to help us. So using this example, why does it make sense that the graph of the direct variation will always go through the origin? Why does it make sense? Well, what if 0 people order food? Yeah, no money. Okay, so if there is no input, meaning if 0 is the input, then there's no output, meaning, not meaning that there's no input or output, but meaning if the input is 0, then the output is 0. That could be worded a little better there. Okay, so we can use this to help us graph an equation that's written in in this direct variation form. We are going to use the slope, which is also the constant, we prove that they are the same, to count from the origin. I know that sounds weird right now. We will do several examples in a moment. I need to do my origami again. That is one thing in life that I do not excel in. If you can fold a little paper crane, you're one up on me. Okay, here we go. I'm gonna see if I can zoom in without making you nauseous. Oh, I need to move the paper. Okay, here we go. So this says y equals 4/5 of an x. So this is my constant. This is also my slope. So both of these are positive. Remember that slope is rise over run or up and down over left and right. Remember, up and right are positive, down and left are negative. So if my numerator is positive, I'm going to travel 4 up. And if my denominator is positive, positive is also right. I recommend that while you're getting used to this, that you actually label up your slopes with those little arrows. So we had a positive 4 over a positive 5, so that means 4 up and 5 right. From where? From the origin, from 0, 0. So let's make a point there, because we know it's going to go through there. Now from here, I'm going to go 4 up, 1, 2, 3, 4. Don't put a point down yet. And also 5 right. 1, 2, 3, 4, 5. And now I can just connect the dots. Look at me, I'm prepared this time. I didn't have to creatively find something in the last minute. There's the line. You just graphed a line. Isn't that cool? Ruh-roh. What if my slope is just a whole number? I see that I'm going to have to go 3 up because it's a positive 3. But what about my left and right? What would 3 be as a fraction? It would be 3 over 1. Right. So that means, and that's also positive, over a positive 1, or 3 up over 1. Which direction? Right. From the origin. You always know that point's going to be right. Okay, so from here I'm going to go 1, 2, 3 up. Don't put a point down. Now put a point down once you've done 1 to the right. Make sure you use a straight edge. Please don't do it by hand. Okay. Ooh, this is where this gets confusing. For now, I'm just going to summarize it with this. If you have a negative, you may choose whether you want the negative to belong to the numerator or the denominator. I'll show you in a second how that makes sense. But for now, let's just graph an equation. So let's just say that this negative goes with a 2. Okay? So I have a negative 2 over a positive 3. And so now we could say then we're going to go 2 down, because remember, down is negative, and over 3 right. So from the origin, 2 down, 3 right. Ooh, look at this. We had a negative slope, and now look, my line is going in the direction of a negative slope, which you have been learning. See, these were positive, and they all went like this. Now we have remember slope guy? Remember this? Yeah. See how it matches? It all comes together, right? Okay. Let's talk more about this negative. I'm going to zoom back out a little bit because I kind of just rushed through it here. Let me please explain to you a little bit more about this deal about the negative. Is there a difference between negative 2/5 or negative 2 over positive 5 or positive 2 over negative 5? Is it the same or different? Okay. Well, what this means is, let's take the negative off, because the negative means basically the opposite, right? Well, this would be 2 up and 5 right. So this would be the opposite of 2 up and 5 right. So instead of 2 up, let's go 2 down. Instead of going 5 right, go 5 left from the origin. 2 down. Oops, made a mistake there. Change one or the other, but not both. Because by changing the both, I just created a negative over a negative, which is a positive. So, sorry. So 2 down over 5. 1, 2, 3, 4, 5. And it seems to work because that's a negative slope. So just in case I confused you with my goof above, if I had just done 2/5 up to right 5, it would have looked like this. See how they're the opposite? They make an X. Okay, cool. So this is positive 2/5. This is, it'd be helpful if you could see, this is negative 2/5. Okay, sorry for that goof there. So this is still right. You could also do 2 up, 5 left. 2 up, 5 left, and that would also work. Okay, did I throw my disclaimer yet? I typically start my lessons with that. We do our best to, I do my best to do a great lesson for you, but it's not going to be perfect. Okay, so this would mean, because it's negative, now we have the negative in the numerator, that means 2 down. And 5, because it's positive, right. Again, from the origin. Origin, 2 down, 1, 2, 3, 4, ooh, 5 right. Look at there. It looks a lot like this one. Now the negative has moved. Now this is positive 2 over negative 5. That means 2 up and 5 left from the origin. 2 up, 1, 2, 3, 5. That's not left, Mrs. Rones. 2, 3, 4, 5. Maybe I shouldn't do these videos in the morning. A little rough. There you go. Look, they're all the same. So does the placement of the negative matter? No, it does not. You can change it to suit your purposes however you want because you're going to come out with the same darn thing. Cool. If any of that was confusing, I strongly recommend that you go back through, watch it again all at once without being distracted by taking notes. Perhaps to refer to your textbook. That will also help you. And another thing that will help is homework, because practice makes perfect. Okay, that's going to be great. For this section, it says, find the slope and the y-intercept of the line whose graph is shown. This doesn't make sense because I'm looking at the wrong homework assignment. 1 second. Oh, try again. 4, 5. Sorry. Determine if the graph represents a direct variation model. Remember the idea that direct variation always goes through the, I'm not going to tell you. You have to look at your notes. And so you can tell me yes or no if these represent a direct variation relationship or not. I will tell you that that is in your notes at the bottom of the front page. Okay. This next section says to graph the equation, then find the constant and the slope. So on your coordinate plane, number it up with 4.5. This is lesson 4. And so here, my constant 2 is in the K spot. It's also the slope. Spoiler, these numbers are always going to be the same, right? Now, if your slope is 2, 2 as a fraction is 2 over, 1. And both of these are positive. So that means I'm going to travel 2 up and 1 to the right from the, origin. 2 up, 1 right. So it'll look like this, using a straight edge from one side of the coordinate plane to the other. And so that's how you do that. Okay, for the next section, it says that these variables, the x and y vary directly. Use the given values to write an equation that relates x and y. So you need to refer to what we did in our notes here to write an equation. So let me show you. If I have, I'm going to skip to a harder one. Let's do 13. If x is 3 and y is 12, and the equation for direct variation is y equals kx, that means that 12 equals k3. K is being multiplied by 3. The reverse of multiplication is division. What I do on one side, I do to the other. So 4 is k. So I know what k is, but I have not yet written an equation. And this is where kids get goofed up. From here, now I can write an equation that I can use in future situations. So like going out to dinner, the example that I used before in our notes. If I know that dinner is going to cost $4 a person in this case, then this is an equation that I can use for the future. How much will it cost at $4 a person for a certain number of people? Okay, so then on here you would write y equals 4x. Cool. All right, we're going to stop there so that I can do the rest of these with you in class, because I just think that would be more fun. If you want to look at them, you can, but you don't have to. If I have lost you, if you need more help, please do not hesitate to email me. Here, you are never a bother to me. Happy to help. Thanks, guys, and I will see you in class. Bye.